Hello, my name is Ayana Harris. I'm a 7th grade student at St. Mark's School. Today I'm going to interview Dr. Zook about eclipses.
Your whole feeling of the light changes. My memory is that during totality, when the moon is covering up the sun completely, so it gets dark enough that so the sky gets dark enough so that you can see bright stars in the daytime. If there are any planets close to the sun, you can see them. The color of the sky sometimes is kind of greenish. The light just has this different feel. And so it's not the same as the colors we associate with sunset, which is what you kind of might think. Isn't this kind of like a sunset in the middle of the day? Well, no, it's not. Let's see. Then, because it's getting dark, all the animals that are active around dusk think it's dusk, and they become active. So the ones I really remember from the first eclipse I went to go see, which was in Canada, was the mosquitoes come out. But other nocturnal animals become active as well. So if you go see an eclipse on land, you kind of want to look and listen for that, if you're in a place where that is likely to be visible. And something else that's fun about going to see a total eclipse is the reaction of the people around you, because typically, although lots of times eclipses are in remote areas and sometimes they're difficult to get to, but like this eclipse is not going to be difficult to get to. If you live in Madras, Oregon, which is the nearest town to where we're going to be, those folks can just walk out in their backyards and watch it. So most places along the eclipse path that are even kind of close to a town or larger, you'll have a lot of people kind of in the immediate vicinity watching the eclipse. And when what's called first contact happens, when the moon first starts to slide in front of the sun. That's called first contact, and somebody will say, "Oh yeah, first contact! Whoa, okay." People get mildly excited about first contact. And then at the onset of totality, everybody just goes nuts, and they start cheering and whistling and stuff like that. And then, I guess that's called second contact. Then when totality is over, then they just go, that didn't last long enough. And then about that point, everybody starts packing up to leave, because the last part of the eclipse, the eclipse isn't really considered to be over until the moon has completely uncovered the sun. But since the last half of the partial phases are really just like the first half of the partial phases, just running backwards in time, those aren't so exciting after totality is over. Down here where the eclipse will be partial, don't stare at the sun. I'm sure that people have been telling you that in your science classes since you were in kindergarten. It's true, don't stare at the sun, because you can damage your vision that way. It's partially because the sun is bright. It's partially because what damages the retina of your eye, that's the light sensitive part at the back of your eyeball. A fair amount of the radiation that we get from the sun is what's called infrared, which sometimes are called heat rays. And so basically you can cook your retina if you look at the sun for too long. And as you can imagine, that's not good for your vision. And you don't have any pain receptors in your retina, so you have, usually, when you're doing things that are dangerous, something will hurt. Your eye doesn't work that way. Nothing will hurt when you do this, so you won't find out that you've done something until it's too late, and you realize, oh man, I've got this kind of little fuzzy spot where I used to be able to see what's going on. Really not very much, except that it causes all these people to go pack up and leave where they live to go see the eclipse. But what it does is basically local. So, you know, it gets dark, the nocturnal animals come out, the temperature drops. You know, you're not standing in a brightly lit field anymore, you're standing in a big shadow, and it gets kind of chilly. It usually doesn't get that cold. I know, actually this has happened to me twice at a total eclipse. Remember, actually the very first total eclipse I ever saw was in, as I said, was in Canada. And so we went to the place we picked up to go see the eclipse. And you know, and the weather, you know, the sky was starting to cloud up, and the clouds are getting thicker and thicker. And I think maybe something like a half an hour before the onset of totality, it started to rain. And we were thinking, should we pack up and leave and see if we can find someplace else? We thought, you know, well, we don't know where it is. This was in 1972, so this is before the internet. You couldn't like download weather satellite photographs and say, okay, there's a whole break of the clouds right there. So, okay, let's just stay where we are. So, about 5 minutes before totality, the rain stopped. There's a break in the clouds, right in front of the sun. This patch of sky right in front of the sun stayed clear for the duration of totality, and then 5 minutes after the end of totality, you know, clouds had rolled back in, and we decided it was time to leave. And I've told that story to other people because, let's see, I went to go see the eclipse in 1999, which was in Europe. I was in Europe anyway. And the same kind of thing happened there, not for quite as long, not as dramatically, but it was overcast, and then there was a break in the clouds about halfway through totality, and so you could see the corona. You see, okay, yeah, they're not making this up. This really happens. And then, you know, 2 or 3 minutes later, I don't remember if the clouds rolled back in first or if totality was over first, but you know. But I've told the story to other people who've seen eclipses, and apparently that's not uncommon. I don't know if like the shadow of the moon cools off that piece of the sky enough that the clouds kind of drop all their moisture and clear off temporarily, but apparently that's not uncommon to have happened during a total eclipse. You know, the sun's pretty big, the moon's pretty small. So this alignment happens pretty closely, more often than you might think. So in fact, we get a total of 5 eclipses every year, 3 of one kind and 2 of the other. So 3 solar and 2 lunar, or 3 lunar and 2 solar. Probably about half of all eclipses of the sun are, only about half or so are total. And they aren't always total someplace that's easy to get to. I remember there was an eclipse, it was about 2007, and the path of totality was like just in northern Greenland. So only really hardcore eclipse chasers went to go see that one, you know, because I think it was like inland in northern Greenland. So, and I think it was in the fall or winter, so kind of the worst possible time to be visiting Greenland. And you know, and even when the path of totality is not someplace that's really hard to get to, it's sometimes someplace where the weather is inclement. Often it's someplace where, I mean, for example, if the path of totality goes through someplace in the tropics, the chances are fairly good the weather's going to be cloudy that day, just because the weather is frequently cloudy in the tropics. So that's one of the reasons the eclipse on Monday is a big deal, because a big chunk of the path of totality goes through places where we're pretty sure it's going to be clear. Because, you know, if the weather's cloudy, You can't do a can't do a repeat. The weather's just going to be cloudy. So so when you're picking a place to go see an eclipse, one of the things that you want to keep in mind is, okay, what's the weather going to be like? Is it likely to be overcast? Am I likely to get clouded out? It kind of depends on what kind of eclipse it is and how hardcore you want to be about it. So if it's a partial eclipse, you want to make sure that you have either gotten a pair of these nice, appropriately safe eclipse glasses to watch the eclipse with, or you can build a pinhole camera like I had you folks do earlier. Oh good, you brought yours. This is the Mark II pinhole camera with a shoebox. Okay, so this is a shoebox with the lid off, but if you look at one side, actually cut a hole in the cardboard and then taped a piece of foil on the other side. Can you see, can the camera pick this up? Okay, and then I'm sure the camera will not pick this up, but there's a pinhole here. And so if you hold this up to the sun, actually probably you want to do this. So you need to point the pinhole at the sun, and if you're holding the shoebox right, then you get an expanded image of the sun at the back end of the shoebox, and it's providing shade so you can see the image of the sun. And this is really great for looking at partial stages of the eclipse, because then you get a nice enlarged image which you can see pretty nicely. And as you can probably tell, it doesn't take very long to make a pinhole camera. If you want to do something a little more serious, and for example, if you're an amateur photographer, you might see about getting a solar filter for your camera so that you can photograph the partial stages of the eclipse. But for a partial eclipse, you're probably not going to do more traveling than maybe to a school parking lot where lots of other people are going to be. But for a total eclipse, that obviously is more complicated because, for example, I'm going up to Oregon. And we actually started planning our trip. I teach at Pomona College, and one of the other astronomers and I are taking a bunch of students up to Oregon for the eclipse. And we actually started planning this almost a year ago. So we, looked up places to stay. We made reservations for campsites. We decided, okay, what kind of equipment are we going to take? And neither my colleague nor I specialize in solar astronomy, and so we're not going to try to make really heavy-duty scientific observations. But we're going to take some cameras. We have a little telescope that's designed specifically for looking at the sun, so it has a built-in appropriate solar filter. So there's kind of long-range planning like that you have to do. Right now, we're kind of at the stage of making sure that everybody who's coming has appropriate camping equipment, because we're going to do a lot of camping to hold our expenses down. Let's see. For the day of the eclipse itself, okay, the place we're going is on the outskirts of Madras, which is a small town in Oregon. I think the population is about 10,000 people. And people who do these calculations routinely say, oh, we think there's going to be about 100,000 people in the Madras area to see this eclipse. So that's 10 times as many people as they're used to. So we're figuring, okay, we probably can't count on getting gasoline the day of the eclipse. So we need to make sure that our gas tanks are full, probably like the morning of the day before the eclipse. Let's see. We're planning on taking enough food and water, especially, so that we can be in the Madras area from Sunday night to Tuesday morning if the traffic doesn't clear up. We're not even thinking about trying to get out of Madras the minute totality is over, But we have no idea how long it's going to take traffic to clear, because it's not a super remote area of Oregon, but not a heavily traveled area. There's not a big freeway like the Foothill Freeway going through Madras. So it's going to take a while to get all those cars out of that area. So we're planning ahead for that. We've told everybody, bring sunscreen, bring a floppy hat, bring a long sleeve shirt, stuff like that, because, we're going to be standing out in the sun for, probably at least 3 or 4 hours. And it's true, we're only going to be looking in the general direction of the sun for like 2.5 minutes around totality, and every so often during the partial phases of the sun, of the eclipse. But we'll be out in the sun, out in the middle of the field for a long time. So we're doing that kind of preparation is what you would do if you're going to the beach, planning on spending all day at the beach.